Good morning, sir. I am Savant Solanki of class 11th B, and now I am going to explain the topic of maths called sequence and series. Now, I am going to explain the topic series. A series is a finite or infinite according as the number of terms. The corresponding sequence is finite or can be infinite. It is the study of series is a major part of calculus. Series are used in the most part of the mathematics. Even for studying finite structures, it is also used in physics, computer science, statistics, and finance. Series can be also explained as A1, A2, A3, A4, and many more, etc. Series defined as the operation of adding A1 after the other. A series may be called as infinite series. Now, for the further topic, my friend Shiva Atre will explain.
Morning, sir. I am Shiva Atre and I am going to explain the topic sequence. Sequence, a succession of numbers arranged in a definite order according to a given certain rule, is called sequence. A sequence is either finite or infinite depending upon the number of terms in a sequence. The number of elements is called the length of the sequence. A sequence can be defined as a function whose domain is either the set of natural numbers or the set of first n natural numbers. The position of element in a sequence is its rank or index. The elements has index 0 to 1. For the further topic, I will call upon my friend Ayush Upadyay.
Good morning, sir. I am Ayush Upadyay and I am going to explain the topic arithmetic progression. An arithmetic progression or arithmetic sequence is a sequence of numbers such that the difference between the consecutive terms is constant. For instance, the sequence 5, 7, 9, 11, 13 is an arithmetic progression with the common difference of 2. In the initial term of an arithmetic progression is a1 and the common difference of an successive member is d, and the nth term of the sequence is find out with the formula an equal to a plus n minus 1 d. A finite proportion of an arithmetic progression is called a finite arithmetic progression, and just called an arithmetic progression. The sum of an finite arithmetic progression is called arithmetic series. Geometric progression. A geometric progression, also known as a geometric sequence, is a sequence of numbers where each term after the first is found by multiplying the previous one by a fixed non-one number is called the common ratio. For example, the sequence 2, 6, 18, 54 is a geometric progression with common ratio 3. Similarly, 10, 5, 2.5, 1.25 is a geometric sequence with common ratio 1 upon 2. Examples of a geometric sequences are powers r to the power k of a fixed number r, such as 2 to the power k and 3 to the power k. The general form of a geometric sequence is a, ar to the power 1, ar to the power 2, ar to the power 3, ar to the power 4.
The behavior of the geometric sequence depend on the value of the common ratio. If the common ratios is positive, the term will be all the same sign as the initial term. The negative term will alternate between positive and negative. Greater than 1, there will be exponential growth towards the positive or negative infinity. The progression is a constant sequence between -1 and +1 but not 0. There will be an exponential decay towards 0. -1. The absolute value of each term is the sequence is constant and the terms alternate in sign. Less than -1 for the absolute values, there is exponential growth towards unsigned infinity due to the alerting sign.
Geometric sequence show exponential growth or exponential decay as opposed to the linear growth of an arithmetic progression such as 4, 15, 26, 37, 48. This result was taken by T.R. Metellus as the mathematical foundation of his principle of population. Note that the two kinds of progression are related. Exponentially, each term of an arithmetic progression yields a geometric progression, while taking the logarithm of each term in a geometric progression with a positive common ratio yields an arithmetic progression. An interesting result of the definition of the geometric progression is that any three consecutive terms a, b, c will satisfy the following equation: b square equals to ac, where b is considered to the geometric mean between A and C. These are some of the formulas of sequence and series. It is differentiate between arithmetic and geometric, and it is categorized into three categories: sequence, finite series or sum, infinite series or sum. And here are the formulas. Now, at the end of this project, it was submitted by Shiva Atre, Savant Solanki, Ayush Upadyay of class 11th B.